Hi guys, welcome back. Today we're going to look at the replication I made of just the natural language processing of the paper Identifying Monetary Policy Shocks, a Natural Language Approach. And this is by Aroba and Drexel. So I replicated this paper in Python, and I have all of my Python code here in a Google Colab. And so you can view this Google Colab and execute different code blocks and actually run the paper just as you would normally run it in Python. And then I have directions here. First, you're going to want to go to the links below here. I have a zip file link to my Google Drive and then a Excel file link that's also in my Google Drive. And you'll want to download these two files and put them in your own Google Drive in a folder called FOMC Docs. And then once you have that folder with the zip file and the Excel file, you can run this program without issue. Here's the actual paper. And this paper was conditionally accepted at AEJ Macro. So if you want a more in-depth look at this paper, I suggest you check it out. Just for this video, I won't go into detail or in depth about it, but there are some great processing techniques here that I want to show you. And we're actually going to replicate some of Drexel and Aroba's work here. So in this paper, the authors look at FOMC documents. These are Federal Open Market Committee documents from the Fed. And so they analyze 772 PDFs from the US Federal Reserve. And they analyze the text in these PDFs. They actually use our programming language, but we're going to use Python. They analyze the text and identify economic concepts, and then match the economic concepts to another dictionary. It's called the Lawford-MacDonald Master Dictionary. And this is a dictionary for economics and finance, and it gives sentiment scores, positive, negative, and otherwise, for certain words and phrases. I'll show you some of them as an example. So if you open the .csv file, you'll see all the words here in the first column. These are in alphabetical order. And then the other two columns that we want to pay attention to are negative and positive. The authors just look at negative and positive sentiment for words. And so in these FOMC documents, they match the economic concepts to words in this dictionary. And then they acquire the sentiment for those words. Then once they have the sentiment for the words, they find contextual sentiment, the sentiment for 10 words before the concept and 10 words after the concept. And then they look at the concept itself and combine the sentiment for that concept with other concepts. So the first block that we have here is the import block. If you look at this import block, we have a couple things here that are a little different than what I've done previously. We have import OS and import zip file. That's specifically for running this program in a Google Colab. And then what we use to read in the text from the PDFs is PyPDF2. And this is in the context of Python. The authors may have used something similar in R, but I wanted to do this in Python because I've been using Python and I really enjoy it. So these are a couple new packages or modules in Python that we haven't seen before. And you can see here I have the code blocks on the left. These are the code blocks in Google Colab. So I'm going to hit this play button here, and this will execute this code block. Now when you run this code, you'll get a prompt to mount your Google Drive, and you'll want to accept that and go through that process. You want to mount your Google Drive to Colab. Basically, it's allowing Colab access to your Google Drive. And you can see here in this little space below the code block, the output, and it's just showing some packages that have been downloaded. The next code block is to mount your Google Drive. Now in using Colab, I had some issues before with mounting my Google Drive. I mount the Google Drive as normal, and then I unmount it and mount it again. So it's flush and unmount. I put this in here just as a backup, just in case you have some issues mounting your Google Drive. So I'm going to go ahead and run this. So this is what you'll see. You'll want to click Connect to Google Drive. It's going to ask you to sign in. So I've just mounted my Google Drive, and when you run this program yourself, you will mount your Google Drive, not mine. And you can see some of the files here in that drive. Now, if you have the zip file and the Excel file in that folder, FOMC Docs, in your Google Drive, then you're ready to extract PDFs from the zip file. And you can see the processing time here next to the play button. It says 32 seconds. So just to recap, you're going to mount your Google Drive, and you want to put the zip file and the Excel file in your Google Drive folder. That's FOMC Docs. And then when you run the next code block, it will extract the files from that zip file. And there should be 772 PDFs. Now you're good to go. The next code block here is for global constants, and these are things that don't change in the program file. There are no for loops here. This is basically data that we're going to use in the main execution block, the main part of the program. So we're giving that main execution block data that's constant. It's not changing. So identify a date pattern, and this is for the PDF files. And then we have 3 lists here of singles, doubles, and triples. And these are the economic concepts I was talking about. These are concepts that the authors identified that relate to the economy. Borrowing, for example, is one concept, and it's one word. So the authors call that a single. Employment cost is another concept, and that's 2 words commonly found together. So that's a double. Aggregate demand, double. A triple would be 3 words commonly found together. Advanced foreign economies, compensation per hour. These are called triples. And in replicating this paper, the NLP of this paper, I used ChatGPT, and ChatGPT calls these things unigrams, bigrams, and trigrams. So keep that in mind if you use ChatGPT for coding. They sometimes use different terms, but really it's not an issue. The more general term for these phrases of singles, doubles, and triples, unigrams, bigrams, and trigrams is n-grams. You might hear me call them n-grams here. I also made 2 dictionaries. One is an include dictionary, the other is an exclude dictionary. These are n-grams that we want to associate with the main n-gram. So the main n-grams are the singles, doubles, and triples in this list here. So the main n-grams are keys in the dictionary. They're the first entries here in quotation marks. So the main n-grams, or main economic concepts, are keys in this dictionary, include dict. For example, borrowing. We saw that before as a single. Well, borrowing is really similar to borrowers. So if we're looking at the sentiment around borrowing, we also might want to look at the sentiment around borrowers. So we're actually going to combine the sentiments of borrowers and borrowing and associate the sentiment with borrowing, the key in this dictionary. So we add the sentiments together. Similarly for banks, we want to add the sentiments of bank, banking, and bankers. If you look at the exclude dictionary, it's just the opposite. We have these economic concepts like banks, and when we look through the FOMC documents, we're going to find instances of district banks. And whenever we see district banks in the FOMC documents, we don't want that sentiment to be associated with banks. We want to exclude that sentiment. And so we subtract the sentiment of district banks from the main economic concept of banks. So again, the keys in this dictionary are the main economic concepts, and the values are the economic concepts that we want to include or exclude from the sentiment. So I'm going to go ahead and click play. And because these are global constants, this will take very little processing time. So again, those global constants, that's some of the data for the main execution block. That's how you can kind of think about it. The next block is functions. And for this replication of the NLP, I have 3 different functions. You can see them here. It's load LM master dictionary, find n-gram sentiments master, and apply inclusion exclusion. Load LM master dictionary is going to load that Excel file from Loughran McDonald, and it's going to associate words with their negative and positive sentiments. And it's going to return a dictionary called LM lexicon. So this is a function that I define in the program, and it's kind of like a separate little program. And when we define these functions, we're actually going to use them separately in the main execution block. So it's like we have 3 separate little programs that we're going to use and call in the main execution block. And for these functions to work, we just have to change the arguments here in the function, how we define it. And these arguments will change based on how we define the elements in the main execution block. The second function is find n-gram sentiments master. And for this, we calculate the actual sentiment of the n-grams. And so in this function, I have several for loops. And basically, I'm keeping track of the date and the text and the n-grams. And then I calculate the sentiment score. The sentiment scores here are going to be positive or negative. So in our program, we want to assign a value of 1 for a positive sentiment and a value of -1 for a negative sentiment. So for every n-gram we find, we want to find that base sentiment score, either 1 or -1. And if we don't find a match in the Loughran McDonald dictionary, it's going to get a score of 0. And then we want to find the sentiment before the phrase, before the n-gram. So we look at the 10 words before the n-gram. And then we look at the 10 words after the n-gram. And we assign sentiment scores to all those words. Finally, we get an adjusted sentiment score, and that's the base sentiment score plus the words before and the words after the phrase, that main n-gram. As we go through and we loop through this text, we want to keep track of the total number of words because we're going to use that number for scaling. And this returns a data frame. It's a data frame of adjusted sentiment, total words, and dates. And even the context is within this data frame. So I have the contextual text surrounding the n-gram. The final function is apply inclusion exclusion. And this is where we combine the included sentiments and the excluded sentiments. So we add the included sentiments or subtract the excluded sentiments from those two dictionaries in the global constants. So I'm going to go ahead and click the play button on this. This should process very quickly. These are just functions. We're not actually executing the functions with data. We're just defining the functions. We're going to execute these functions here in the main execution block. And there we go. So those are the three functions: load LM master dictionary, find n-gram sentiments master, and apply inclusion exclusion. Let's go to the main execution block, and this should take a significant amount of time, probably about an hour and a half to execute. So keep that in mind. We have a lot of PDFs here, and we're doing a lot of processing. So we would expect this to take a long time. Make sure you have that time available to process this. And if you're doing this on Python on your own computer, this is going to take a significant amount of memory. So here's the main execution block. I won't go into too much detail on this. Basically, we're looping through the PDF files. We acquire the dates from the file names, and we acquire the text as well from the PDFs. I create grouped data, which is a dictionary with the dates as keys and the text as values. And then when looking at these PDFs, sometimes PDFs have the same date, and so that's for different books. So we want to combine the text from those other PDFs if they happen on the same date. And so that's what I do here. I merge text by date. Then I specify the file path for the dictionary and load the dictionary with that function we defined previously, load LM master dictionary. This is what we're going to refer to match our n-grams and get sentiment scores. Now, if you remember those three lists of n-grams, singles, doubles, and triples, we're going to combine them all in one big list and call it all n-grams. And that's basically because we don't want to use a process like a for loop to loop through 3 times when we can loop through 1 time and just get all the n-grams at once. So here's the main execution part with a for loop. We're performing sentiment analysis by date. Remember, we merged all the text by date. So for each date, we have all the text associated with that date. I go through the steps of cleaning the text. We know these steps before. We've done these steps before in previous videos. There are some common fixes. When we try to read in PDFs, sometimes we're looking at different typefaces or different font faces, and sometimes the reader doesn't get the entire word. It doesn't get it correctly. So here are some common fixes. Like some things that I noticed is devel. Sometimes the full word development isn't acquired. Sometimes it's just devel. So we're going to put in some common fixes here so that when we find devel, we're just going to associate that with development. Same with prices 3. We're going to associate that with prices. And then at the end of the cleaning, we're going to get merged text by date. And again, with dates as keys and text as values. And after we have that cleaned text, we're going to create a data frame. And we're going to call it dfall. And we're going to create this data frame from that function, find n-gram sentiments master. This is what's going to create our sentiment scores. So we're recalling that function we defined previously. So in that data frame, we have n-grams and their occurrences by date and their sentiment scores. Well, it's highly likely that many of those n-grams occur frequently. They may occur frequently within one document, and certainly they occur frequently within a certain date. So basically, we want to aggregate all those n-grams and sentiment scores by date. And so that's what I do here. And then I make a full grid of the dates and n-grams. So I did this so that my program would function well with even a small sample of text. As I was replicating this paper, I found that the processing time was really long. If we have 772 PDFs, and I just want to make one small change to the program to see if it works, well, I have to wait an hour and a half. Well, what you can do and what I did is I created another folder, a test folder, where I can debug and do some trial and error. So I made a test folder with maybe 15 or 20 PDFs, and in so doing that, many of the n-grams aren't found because we don't have a large enough sample of PDFs, and then my program wouldn't work. To get around that, I created a grid of all the dates and n-grams, and that means that I can fill in zeros and ones if I have some missing data, and I still want to complete the program. And so I explain that a bit here in this line of text. Basically, I fill in the missing sentiment scores with 0 before standardization and the missing word totals with 1. Now, like I mentioned, if you have 772 PDFs, this shouldn't be an issue, but if you have a small test folder and a small sample of PDFs, you'll want to do this. Basically, you want to make sure all the n-grams for all the dates have a sentiment score, at least a 0. And you want to make sure that the total words are at least 1. Then you can find a scaled sentiment score and a standardized sentiment score. And you want to standardize the sentiment by n-gram. And I'll explain that in a second after we run this and we look at the pivot data frame. You'll see more easily why we standardize by n-gram. But basically we want all the sentiment scores for a single n-gram, and we want the mean of those scores for just that n-gram and the standard deviation just for that n-gram. And then we can find a standardized sentiment score. The pivot data frame is here. So pivot DF is a data frame with the first column is dates, and the first row will be your n-grams. And then the data in the center are sentiment scores. And so we're going to see what this looks like after we execute this code block. But creating a pivoted data frame like this is important. Makes it very easy for plots and regression analysis and sharing Excel files. Now we're going to export to Excel, and the file path we're going to use is content/sentiment scores. And this is going to be in your content folder in Google Colab. Okay, and it's going to have the title sentiment scores. Let's go ahead and run this, and you'll be able to see this. I'll show it to you here in a second. So I'll see you back in probably an hour and a half. All right, and we're back. So the execution time here says 59 minutes, but it actually was interrupted. It stopped and then started back up again. It's about an hour and a half. I think the time that you run this program will be a factor too. Like if it's in the middle of the day, it might take longer because of traffic and things like that. Anyway, we got this. So let's check out content/sentiment scores. And here it is, sentiment scores.xlsx. I'm going to double click and we're going to open this up. Here we have our sentiment scores. So this first column is the date column. You can see the dates listed here in the bar here. Then each n-gram is listed in the first row. And these are standardized sentiment scores. So a score of 0 would be no sentiment, either positive or negative. And these are standardized sentiment scores, so the mean will be 0, and a score of 0 has no sentiment, either positive or negative. The greater the positive sentiment, the higher the positive score. The lower the sentiment, the more negative the score is. The more negative the sentiment score, the lower the score is, below 0. So you can see this starts in October 1982, and if we scroll down, it ends in December 2016, and these standardized sentiment scores are within each n-gram. So the standardized sentiment scores takes the sentiment score, say for October 1982, and you subtract the mean and divide by the standard deviation, and that's the mean of this series here for Argentina, all of the values, and then also the standard deviation. Then that mean is used for the standard deviation of the series. So the standardized sentiment scores are great for visualization purposes, which we'll see here in the plot section. So the main outcome here from the main execution block is that pivot DF, and that's a data frame of those sentiment scores, the dates, and the n-grams themselves. Now the plot section, I just want to show you a plot of two n-grams and their sentiment scores over time. The difficult part of this project for this program is getting pivot DF here. Once we have pivot DF, we can do our regression analysis, we can do our visualizations, all that's good. But making sure we have the rest of this correct is sort of the hard part. So now the plot section, let's go ahead and execute this, and it's already done. You can see the output here at the bottom. We have sentiment scores for credit and for oil prices. Now if you kind of look at this for credit, the sentiment for credit in the FOMC documents, all 772 PDFs, we have those plotted over time here. The sentiment score of 0 shows no sentiment, either positive or negative. So it kind of makes sense in this shaded red region for a recession, we see a dip here in the sentiment score. You can imagine credit around this time, 2009, late 2008 maybe, wasn't in great shape, and there was some negative sentiment surrounding credit at that time. If we look at oil prices, around the same time period during a recession, there wasn't much negative sentiment surrounding oil prices, and I think that's because this recession was mostly related to financial conditions rather than oil prices. So this recession wasn't related to oil, but previous recessions were related to oil. Say if we go back in the 70s, we might see a dip here in sentiment for oil prices. So that's it for this project. If you guys like this content and this format in Google Colab, go ahead and give me a like on the video and leave a comment below and let me know if you want to see more videos like this. I recommend you give this program a shot. Just follow the directions here, download the two files here into your own Google Drive, put them in a folder called FOMC Docs, and execute these code blocks. Give it a shot. You can also try to plot different n-grams. I just showed two n-grams here, credit and oil prices, but you can choose any n-gram you want and plot that n-gram. In this plot section, simply change the two n-grams here to plot, and you can choose any n-grams up here in our lists of n-grams, here in our lists of singles, doubles, and triples. So give it a shot and let me know if it works out for you. Thanks, guys.